Hi everyone, welcome to my second video about Simpsons rule, and this time we're going to use our calculator in a different way. Perhaps not quite so complicated as the first method I showed, but it will be a little bit more tedious, there'll be a bit more time consuming. So let's begin. We've got here a lovely question asking us to calculate this integral using 8 partitions and using Simpsons rule. So as normal, we would start by finding the width of each partition. W equals B minus A over N. In this case, our upper limit is E, subtract 1 divided by 8. Now, that's where I'm going to reach for my calculator. Here we go. Now, in order to use E, it's not like I don't have a key like pi, which just has E. I've got E to the power of X. So if I put E to the 1, that will just give me the value of E. Subtract 1 and divide by 8. And there I've got my value for W. Now that's an important number for reuse, so I will store that into, well, I might as well store it into W, so I remember which one it is. So there's the W down there. That one's stored. So let's write that down. That is 0.215. Nice. Now here comes Simpsons rule. The integral from 1 to E of e to the x ln x dx is approximately. Now I've just copied out, that's a cut and paste of Simpsons rule from your formula sheet, so that's what you'll have to work from when you're doing this under exam conditions. Let's just do W over 3, and we had f of x naught plus. Now, the formula sheet just lists them out individually as f of x1, f of x3, and so on, f of x2, f of x4, and so on. But we can use the summation. So, sum of f of x, and this is the x's with the odd subscripts, plus 2 times sum f of x with the even subscripts. And don't forget the last one, f of xn, sits there by itself. So our values, if I was to do a very rough sketch of this graph, I think it goes something like that. That would be the value of A, which in our case equals 1. Then the next little spot here would be A plus W. The next one would be A plus 2 times W, all the way across until we get to point B, the upper terminal, and the upper terminal would be A plus 8 times W, because we had that many strips there. Now that, it's always going to be that way. It's always going to be an arithmetic sequence with starting value of A and common difference of W, because that's just how it works. That's when we divide these things up. That's exactly what's always going to happen. So that's a handy little reminder, I suppose, there of our arithmetic sequences, and we'll need to use that in a minute when we're trying to calculate each of these different x values. Now, rather than entering the summation notation on the calculator, I'm going to set this out in a table on my calculator. So here I go. I've already got W stored, that's good. Now let's pop out to the menu and go into the statistics app. And this is more or less like a spreadsheet. I'm going to, there is a spreadsheet inside the calculator, but I find this easier to use. So if you want to go and use something else, well that's fine, you can explore, but this is what I'm happy with. I'm going to start by entering the numbers 0, 1, 2, all the way down to 8 in the first list, and they represent the subscripts on the x's. I'm going to then calculate each of the x values in list 2. To do that, I need to move the cursor up to the top of the list here, and I will be entering a formula, and my formula is literally A, which is 1, here I go, plus W, well, my common difference was W, remember what I stored that earlier, multiplied by, now I'm going to put list 1, there's the word list there, so shift list 1. And what this tells the calculator to do is successively use each value 0, 1, 2, 3 and then store the result in the appropriate place. So there we go. Our lower limit A equaled 1, as we expected. Then the next one is 1 plus a single W, 1 plus 2W, 3W, all the way down until we get to the last one, which, well, it has to be E, doesn't it? Because you would recognise E as the number 2.718, and we were integrating from 1 to E. So that seems to have worked quite nicely. Now they're just the X values. In list 3, I want to calculate the function values. So f of x0, f of x1. Now I do the same process. Put the cell cursor here at the top of the column and I start typing. Now our function was e to the x, so e to the power of list 1. Oops, sorry, list 2 is where the x's are stored. Now I'm being a bit cautious. I'm putting brackets around that to make sure that calculates properly. Multiplied by, and I'll use brackets again to be on the safe side, ln of x, and of course x is stored in list 2. So that should work out. These numbers here represent the values of the function. These are literally the numbers that are going to go into the Simpsons formula, these numbers here. Now, I could, if I wanted to, write Simpsons formula down with all of those numbers listed out. That's a way too time consuming for me, especially if I'm trying to do this under exam conditions. Now let's have a look. I note that f of x0, which is that first entry, it appears once. So I'll put a number 1 there in list 4. The next one, that's f of x1, that's one of the odd ones, isn't it? And the odd ones get multiplied by 4. Let's put a 4 in that space. Now, be careful not to look over at the side. Look at the numbers in the list because we have to start our subscripts from 0, then 1. Now the next one here is a subscript 2. That's an even one. Even ones get multiplied by 2. Now if I keep alternating 4, that's odd, then the next one was so 4, then 2, then 4. Then now I'm on my last one, aren't I? Be careful when you get to your last one. Remember, f of xn is just added in with the ones, so I'll put a 1 there. Now those numbers there, a 1 at the top and a 1 at the bottom, and then the 4 and the 2's alternating, are literally doing the job of these coefficients here in Simpsons. Oh, what's happened? Oh, goodness, things are going crazy. They're doing the jobs here. Oh, Simpson, oh, come on, OneNote, don't do this to me. They're doing the jobs of these coefficients here. And of course, there's a coefficient of 1 and a coefficient of 1 sitting in front of that. So, just tidy up that little scribble there. Don't know what was going on. Now, that's all well and good. I've got that stored in my calculator, but I really need to have 1 multiplied by the first function value, and 4 multiplied by this one, and 2 times this one. Well, you guessed it, I come across to list 5, and I'm going to go list number 3 multiplied by list number 4. So list 3 are the function values, and list 4 are the multiplying factors. There they are. List 5 contains the answers that I need. And of course, inside this bracket, it's just adding them all up, isn't it? How will I add these things up? Well, this is where I go into calculations, F2. Always check the settings. So let's go into the settings. Oh, it looks like I've already been in here. We can do either 1 variable stats or 2 variable stats. I'm only really interested in the numbers in list 5. So under 1 variable stats, I've chosen to put list 5 as the place to look. And under frequency, I've just put 1 because I only want each of those numbers to appear once in my calculations. So that's all good. Now that may or may not have had list 5 there. You can change it if it's needed to. So I'll just go back from there, and I will ask for the 1 variable statistics to be computed for list 5 with everything appearing once. There they are. Now I'm really only interested in this one here, sigma x. adding up all the numbers in list 5 comes to 123.44. So that's what I need to put on the working when I'm doing my test. I need to go, W was 0.215 over 3. Then all of this stuff came to, perhaps I need to show slightly more working, 215 over 3, and all of that came to 123.44. So that's going to give me my answer. But what am I going to show in here in order to convince the examiner that I know what I'm doing? Well, to make life easy, I could just go f of, 1 was the value of x naught, f of 1, plus 4 times, now I'll have to put some brackets here, and I wanted f of, let's get the calculator back so I can see what I've got to play with. So if I skip back to here, these are the x values, aren't they? So the first of them is 1.21, so I'll just be a bit approximate, 1.21, and I would go dot dot dot, and then that's the odd ones, plus 2 times, now what's the first of the even x values? So this is really just a bit of window dressing. So that's the first of the even ones where the subscript was 2, 1.43. Let's put 1.43. And there were more of them. And then finally I had f of e. So that line there is window dressing. It's just there to show the examiner that you've substituted. If you were running short of time, I would skip straight from this line to this line, because that's the real work that we want to show. Now, to do this calculation, let's just move back to the regular old calculation screen. You can still see W sitting there. Now you might be wondering where I'm going to get my 123 number from. Well, all is not lost. Let's start this. We need to have W over 3. Then we multiply by, and really that was the sum of all the values in list 5. So if I go to my variable key, notice this statistical menu, then under the X I can access sigma x. That is literally, that was the thing beside where I had the 123 on my previous screen. And if I do that, I get the correct answer. No rounding off. It's all there. And of course, the calculator's disappeared on me, hasn't it, before I had a chance to write that down. So it is 8.837956. The question, for some weird reason, wanted 6 decimal places, and that is units squared. So I'll just take that away a little bit. That was a bit too close. So there is a perfectly adequate amount of working to show. You've written the formula, you've written Simpsons rule. Remember this one in the middle here, I'm considering that this is a nice to have if time permits on an examination, not a must have. The bulk of the work was done in the stats lists on our calculator, and then that shows W, the 3 obviously, and this shows all of the summations with the multiplying factors taken care of to give the answer. Okay, a little bit more time consuming than the previous method, but I think conceptually easier to follow. Thanks for watching.